and share my whiteboard. Okay, now this is the 6th chapter of this book, that is partial fractions. Okay, it's very, very easy. It's a very small topic. We would be able to finish this today, inshallah. Okay, so let's get started. Okay, so like always, we'll start with some definitions. We'll talk about some terms and then we'll talk about the questions. So you need to understand a few terms initially because we have questions related to those topics. So I'll write down the terms on one side. Okay, so let's talk about some terms, okay? The very first term is conditional equation. And yes, although it is easy, but it is very important when we do questions in a bit, you would see that we will be using all these things over there, okay? So a conditional equation, I would not be writing down the definitions, we'll write down the examples only. I'll just read the definition. It is a type of equation in which two algebraic expressions are equal for particular values of the variable. For example, if I talk about the first example, if we have 4x equals 5, and let's say the second one is 2x squared plus 3x plus 4 equals 0, okay? Now these are the two types. Now these are the two types, and what do we see? We see that we have been calling this a simple equation, right? We have been calling the exact same thing a simple equation, but now we know that it is, yes, it is an equation, but it is particularly a conditional equation. Why? Because this is the type of equation in which two algebraic expressions are equal for particular values of the variables. Yes, that is true. Okay. Let's talk about the second term. That is again very simple, identity. So we have been playing with so many identities, like we had three algebraic identities. So if I talk about the first one, I'm just writing down the examples. We have a minus bx equals to ax minus bx. Now this is not an equation because both the left hand side and the right hand sides, they are identical, okay? So this is the difference in equation and identity. These are different for all the values, these are same for all the values of x, okay? And if I talk about another example, so let's do a familiar one. Let's say we have x plus 2 and x minus 2. So what is this? This is the famous quadratic identity where we have x square minus 2 square, right? That is 4 basically. Let's just write it down as 2 square because that would look more easy. Okay. And now we have the third one in which we have rational fractions. Okay. Now this is very simple. We would be having fractions. This means that it would be something of this type. P of x, it would be a polynomial, and then that would be divided by another polynomial. And if I talk about some examples, so again, I can say, for example, x cube minus x square plus x plus 1 divided by x square plus 5. For example, 2x over x square plus 1. Okay. Now let's just read this quickly and then we'll talk about more things. So we started our discussion with conditional equation. For conditional equation, just tell yourself it is the simple equation. It is the thing which you have been calling an equation, and that is the conditional equation. Okay. For identity, the two sides, the left side and the right side, they are identical. And a rational fraction is nothing but a fraction in which you have a polynomial in the numerator and a polynomial in the denominator. Okay, we'll talk about this in the next. The next topic is basically classifying rational fractions. Yeah, but for now, this is what we had to do. Okay, let's just drop this and let's talk about the rational fractions then. Okay, before that, I would like to ask you, Asad and Zahib, is this clear?
Yes, ma'am.
Okay, and what about you, Asad? Okay, he's not in the meeting. All right, so let's talk about rational fractions. Let's talk about rational fractions now. So again, we have two types for rational fractions. One is the proper rational fraction, and then the other one is improper rational fractions. Okay, it's very simple. It's just like a simple fraction. We have two types, proper and improper. The same is the concept over here as well. Okay, so I'll talk about some examples and then you would be able to understand the difference. If I write down some examples for proper rational fraction, it would be 2 by x minus 1. It would be 2x by x square plus 1. And then, for example, another type of proper rational fraction could be 7x squared by x cubed minus 3. Okay. Now, all these are proper rational fractions. Why? Because of this thing that, let's say, if p of x is in the numerator and q of x is in the denominator, so degree of p of x is less than the degree of q of x. This is the only difference, right? Okay. Let's talk about improper rational fractions now. We'll talk about some examples again. Type 1 is x by 3x plus 2. Then we have x square plus 1 divided by 4x plus 1. So what would you say about improper now? The opposite is the case. Here we have again the same thing, p of x over q of x, but degree of p of x is greater than or equal to the degree of q of x, right? Now again, just like simple fractions, we have two types, proper or improper. In proper fractions, we'll talk about the degree of x, okay? So here the degree of x is 0, here it is 1. Again, it's 1 in the numerator, it's 2 in the denominator. It's 2 in the numerator and it's 3 in the denominator. So every time the degree of the numerator is less than the degree of denominator, that is what is proper rational fraction. For improper rational fractions, what do we have? The degree is 1, 1. The degree is 2 in the numerator and it is 1 in the denominator. So what is that? This is improper rational fraction. Okay, now for improper rational fraction, we need to understand one thing. I'll write down a note quickly. Okay. For Improper rational fraction, we should know that. Fractions can be changed into proper by long division. Okay. Yeah, this is what we need to understand. Right. Now, proper should be clear. The degree of the numerator is less than the degree of denominator. What is the improper thing? That we would have either the degree same or it would be greater than for the numerator, right? And whenever you come across improper rational fractions, you need to do long division first, just so you get a proper rational fraction, and then we'll see how to play with that. Okay. So yes, this is the concept about two types of rational fractions. Zahib, did you understand this?
Yes, ma'am.
All right. Then that is good. We just need to talk about one last thing and then we'll talk about the questions directly. Okay. So again, one last thing is obviously the types of partial fractions, because in A levels we have different. Like obviously that is mathematically correct, but now we'll just talk about those types which are needed for NEQ. Okay. About the questions, it's only from the questions point of view. So let's talk about some methods to break up partial fractions. Okay, now let's talk about this. Okay, so it is case number 1. Now case 1 says that if we have again p over x over q over x, it would be a fraction with polynomials, and the condition is such that q of x has only non-repeated linear factors. Okay, every word is important. Non-repeated linear factors. So what would happen in that case? This is what we are going to have. So let's write it down. So let's say we have q of x equals x minus a1, x minus a2, and so on. Let's say we have x minus an. Okay, so we will write down p of x over q of x as simply a by x minus a1 plus b by x minus a2 plus the last one could be, let's say, an by x minus a1, and let's write it as a2. Okay. Now again, we're talking about some cases. We will talk about 4 cases. This is the first case when we have linear factors. Okay, now q of x has only non-repeated linear factors. So whenever we have this is how we break down the partial fractions. Asad and Zahib, did you understand the first case?
Yeah.
Yes, ma'am.
Okay, very good. Okay. So this is easy. That is why I'm not explaining this in depth, because we know how it is and I don't want to waste your time. So let's talk about the second case quickly. Again, in reality, we have other cases as well, But right now, we'll only talk about those which are important from exam point of view. For case number 2, we have Q of X has repeated linear factors. All right. So this means that if Q of X is x minus a to the power n, this is what we are going to have, and n is greater than or equal to 2. Now just understand this type. This is basically the type, let's say we have a fraction in which in the denominator, say you have x minus 1 and then x minus 1. So we write it down as x minus 1 square, okay? And then the numerator would have anything, for example, p of x, right? In such cases, how do we break this down? We break it down this way. So we will have a1 divided by x minus 1 plus a2 divided by x minus 1 square, right? This is for this example. Now, if I talk about the general case, about this one, how would it look? P of x divided by q of x equals, now we don't know what is n would be 2 or greater than 2. So it would be a1 divided by x minus x1 plus a2 divided by x minus, let's write it down as a, yeah, okay. Now what is the game here? The game is that again you would be having a fraction in which the numerator and denominator would be a polynomial, right? It would be having x. And in order to break that down in fractions, we are going to look at the denominator only. If the denominator has one factor that is repeated, by repeated it means it would have a power that would be 2 or greater than 2. You will just break it down this way directly. Okay, so first factor would come with 1, the second one would come with 2, and then the last one would come with the power n, right? So this was the second type. Again, this was simple, but still if you have any questions, please just stop me and tell me that, ma'am, I did not understand this, okay? Is this okay, Zahib and Asad?
Yeah.
Yes.
Hmm. Hmm. Yes, Zahib?
X minus 1 square. I heard that in the A levels it was like ax plus b in the numerator.
Yes, not for this, not for this. Yes, you are correct. We'll talk about that for the third type. Okay, here we have linear factor that is repeated. Okay, it is linear factor that is repeated. So this is different basically, right? You will see, this is what I'll talk about in the third case exactly, but this is not that case. Okay, just focus on this thing. It is linear factor and it is being repeated. So the factor is linear. Those were the cases where we used to have x square plus 1, or let's say x square plus 2x plus something that was irreducible, right? That case was different, okay?
Okay.
Yeah, very good question. Okay, let's talk about the second last type and then we'll talk about the questions. This is case 3. So here what do we have? Q of x has non-repeated irreducible quadratic factors. Okay. For example, let's say we have a fraction of this type. Let's just talk about the types first and then I'll talk about the general case. So let's say we have 2 divided by x square plus 1, or maybe if we have, let's say, 2x divided by x square plus 5, or let's say we have 9 divided by x square plus 2x minus 17, right? Okay. Now, what are these cases? Basically, these are the cases where q of x, forget about the numerator. We don't care about what we have in the numerator. No, we'll only talk about the denominator. If in the denominator we have non-repeated, we only have one factor that is quadratic and it is irreducible. By irreducible, they mean we cannot factorize this. Okay, so we have x square plus 1. We don't have any identity. We do not know any method through which we can factorize x square plus 1, x square plus 5, and then this is the last type, right? Okay, now this is these were some examples, and now if I talk about how are we going to write it down as partial fractions, so this is going to be p of x divided by q of x, where q of x has non-repeated irreducible quadratic factors. So this is going to be ax plus b divided by, and that factor would come over here. It would be ax square, let's say we have the x term as well, plus c. Yeah, so this is the this was the case here. In this case, the difference is that they are irreducible. Let's talk about an example over here and let's see if you guys have understood this concept or not. Okay. Okay, let's say I have 3x divided by this. Okay, so how would you break this down as partial fractions? I'll give you 2 minutes. Think about this and tell me the factors. Okay, everything is on board. You can just think about it and tell me the answer. And if you're telling me wrong, that's completely fine. Okay, so don't worry about that. But just think about this question. Yes, Zahir, what do you think?
Still doing it.
Okay, sure. Sorry.
Okay, like I'm getting a bit confused here.
Yes, okay. What's happening?
Like I am trying to um
Hmm.
I'm not really sure because the equation in the bottom one
Mm-hmm.
uh I'm trying to like do it with the breaking it down with completing square method, but I'm a bit confused.
Okay. Okay, that's completely fine. Okay. Let's look at this. Yes, your approach was very correct. Initially, you need to try, you should try if you can reduce it, if you can factorize it. And if you are not able to factorize it, then you would be going with this choice, right? That it is a non-repeated irreducible factor. So this would be the case. But in this case, if you look at this carefully, what is this? Isn't this x square minus 2 into 1 into x plus 1 square. Isn't it that formula? So don't you think it is x minus 1 square, right?
Yeah.
So basically, I can rewrite it as 3x divided by x minus 1 whole square. And now when I know that it is not a non-repeated irreducible quadratic factor, in fact, it is a linear repeated factor. So it would be a over x minus 1 and then b over x minus 1 square, right? Okay, this is how we will break this down in the partial fractions. So Zahib, is this okay now?
Yes, ma'am.
Okay, very good. And let's talk about the fourth type quickly. So yeah, this is the case number 4. What do we have over here? When q of x has repeated irreducible quadratic factors. What is the difference in the third type and in the fourth type? We have repeated, okay? So let's say we have q of x of this type, ax square plus bx plus c. Now this factor is irreducible. I cannot factorize this. This has the power n, where n is either 2 or it is greater than 2. So for such case, how would we go about this? It's very simple. P of x divided by q of x can be written as a1x plus b1 divided by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c by square, and so on till the last term, right? What you need to understand is that what is this case? This is basically a blend of the second and third type, okay? In the second type, we had repeated. In the third type, we had irreducible quadratic factors. And how have we solved this? Using a blend of both, okay? So we have 1, 2, and so on. The last term would have again the same factor, but with the power n. And in the numerator, what do we have? In the numerator, we have what we have in irreducible quadratic factors, right? So this was basically a blend of both these. So Asad, did you understand this?
Yes, ma'am.
Okay. Zahib, are you okay with this? Because it might be new for you.
Yeah.
Okay, very good. Let's just do an example on our own quickly, and then we'll talk about the past paper questions. Okay. So we need to understand another thing as well, that once we have broken this down into partial fractions, how do we find a and b? Okay, that is also an important thing. So let me take out the example. Okay. This is basically a past paper question. So 7x plus 25 divided by x plus 3 into x plus 4. Now this is the question. You're sitting for your exam and this is what you see. So quickly you will see you have two linear factors which are non-repeated. So it is case number what? Case number 1, okay? Case number 1 was when q of x had non-repeated linear factors. It is case 1. That's good. How do we break this down? We break this down this way. It is a divided by x plus 3, and then it is b divided by x plus 4. Now, don't get confused with A1, A2, ABC. That's completely your choice. You can use whatever you are comfortable with. Okay, that's it. Okay. Both sides are equal. We need to find A and B. So we will do what? We will just use the comparison method. Okay, first, let's just make the denominators equal. So I will write this as, I'll take the LCM, and this is going to give me x plus 3 into x plus 4. And now when I will take this LCM, I'll multiply. What with this factor? I'll multiply x plus 4. So I would have to multiply that with A as well. So that would be A x plus 4 plus, again, this is x plus 4. In order to get this, I need to multiply x plus 3 with this. So I'll multiply x plus 3 with the numerator as well. And that will give me b x plus 3. Now I have two expressions that are equal, this and this. Their denominators are also equal, so I can just compare the numerator. So it is 7x plus 25 equals a x plus 4 plus b x plus 3. Okay, now how do we solve this? By comparison, I will expand this side and this will give me a into x, ax plus 4a plus bx plus 3b, and the left side would come as it is. And we will just separate the coefficients of x, ax plus bx, and the constant one, because how do we solve partial fractions? By comparison. So 7, or let's do it this way. The coefficients of x are 7 equals a plus b, and the constant term are 25 equals 4a plus 3b. Okay. Anything that you have not understood so far, please tell me.
No, ma'am.
Okay, very good. Now let's just simplify this. So a can be 7 minus b. This is a. I'll plug in this value over here, and this will give me 25 equals 4. 7 minus b plus 3b, and that would be 25 equals 4 into 7 is 28 minus 4b plus 3b. 28 will go to that side, it would become minus 28 equals minus 3, sorry. 25 minus 28 would be minus 3 equals minus b. This means that b would be 3. If b is 3, we'll just use 3 here, and that will give us 7 minus 3, that is 4, that is a. This means that my partial fractions would be, this is what I had. I'll just plug in the values of a and b, and I will get the answers. So it is 4 by x plus 3 plus 3 by x plus 4. This would be the answer. So Asad and Zahib, did you understand this completely?
Yes, ma'am.
Okay.
Yes, ma'am.
Very well done. Excellent. Now, finally, officially, we are done with the contents. Let's talk about the questions, and then that's it. Okay. So I will stop sharing this and I'll take out the questions. Again, I did not talk about too many things because this chapter is easy. And I did not talk about extra thing as well, right? I just wanted to talk about what is necessary, the important contents, and that is it. Okay. Now I have to see the screen. Okay. It says 4x equals identity equation. It's, we have a name for this type of an equation. Think about a simple equation as a conditional equation. Correct? That would be 5 by the equation. Let's talk x minus 2 into x plus 2. It is not an equation. It is the left side and the right. Okay with this?
Yes, ma'am.
Okay, very good. Obviously, these questions. And as I've been telling you, the difficulty level would vary from question to question, right? Even this is the case for SAT as well. Zahib knows that. Some questions are easy, some are. Let's talk about the third question. So it says, if px plus qx square minus this a and r are respectively. Now again, basically this question is to find the values of pq, a and b. So I'll give you 2 minutes. Just is wrong, that's completely fine. But just try doing this, okay? You will again do this by comparison. Of x cube is 2 and it is minus, and this is okay. question. Sorry. Yeah. An equation in which two algebraic expressions are equal for particular values of the variable. It is called, right? This is the expression variable that is called a conditional equation. Okay. Then the fifth one says rational fractions are of how many types? We just have two types. B, A. Says 2x minus 5 fraction. Yes, what do you think?
Proper.
Improper.
Okay, so one is saying proper and the other one is saying improper. Let's use correct or the okay. And the degree of data is 2. Okay. If we talk about the definitions of proper and improper, we should know the fraction, the degree of the numerator. Okay, so this we either if we had one, this would have been improper. Degree of denominator, it's just like a proper concept, a proper rational fraction, right?
Yes,
Asad?
ma'am.
Okay. Is let me just check. I've just done this question. Yep, we did. This is the question which I did before. The thing which we did was this question. Could be the case because then by comparing A and B, by some more questions. Okay, this is the question. Is of the form. Yes. Understand what exactly is the type, or if it's one type, or if it's a blend of two types.
D.
D.
Yeah, D.
Okay, and what about you, Asad? What do you think?
A.
A. A.
No, okay, I will also be going with D. D.
Okay.
It's D.
All right. All right. Okay. Let's see. Okay. Let's see. Now, what do we have? This time, this is factors that are non-repeated. One is linear and the other one is quadratic. Factors that are non-repeated, we write down two separate groups. So clearly, this is not an answer. Just a linear factor. So it would be simply a factor. We know that it is a quadratic, irreducible factor. So it would have, the answer would be D. Very well. Excellent. Okay. Let's talk about, okay. Now this is the partial fraction of what? So you need to think about the question basically. Sorry. You need to think about the question basically, and then you would be knowing what exactly would the question be. Yeah. So you have the partial fraction, then you need to think about the fraction which you would have initially. Please think about it and tell me. Just take your time, okay? Don't be impatient. Just think about it and then tell me the answer. Yes. What do you think? Any idea? If not, then obviously the history.
C.
Very
So
well
1
done.
minus.
Very well done. And what about you, Zahir?
Mm, I'm not sure.
Okay, that is completely fine. Okay. Now look, this is what we have. Sorry, not talk about. We have, okay. So we have different factors in the denominator, and the question is to talk about try joining these. So sorry, this is my mistake. This 4, 4 and 2 is coming after. So okay. Because now I am going from the last factor. Isn't this a minus? So it would be 1. And what is this? The minus x into a plus b. So this denominator, it is in c only. That is why it's easy. In the denominators, and then think about the original fraction. Right,
Oh,
Zahir? One is this. So it says an improper used by division to what? Yes. So we do long division to get what? To get a proper rational fraction, right? So this answer, because it is not irrational fraction, if we are writing it down as p of x over q of x, that would be the proper. For example, let's say if I talk about a question, let me just take that out just so you're able to understand this concept completely. So let's say if you had this by -1, how would be things in this case? And once we are done with long division, we are going to get proper fraction plus 1. Get the proper fraction. It could be any constant as well, right? So D is the answer. So did you understand this, both of you?
Yes,
Okay. This time the question is the rational fraction P of x over Q of x is dash then the degree of Q of x. Yes, this is very, very simple.
that-
But whenever fraction, okay, so the numerator, very good. And 3 is dashed rational fraction. Yes. What do you think about this one?
Improper.
But
Yeah, it is improper. Why? Because the degree. So what was the condition for improper of P of x or equal to Q of x? Right? So this was the condition for improper rational fraction. Who did not understand over here, please feel free to ask me.
no questions.
Okay, and what about you, Asad?
Ma'am, can you please repeat the first part of the lecture that you have given, the conditional equations and
Okay. All right. The three terms basically, right?
yes, yes, yes.
Okay. So I'll stop sharing the screen because we are done with the questions. I'll take out the whiteboard again. And yeah. Okay. So it's just three things, very simple. You would be able to understand this now. The first type was conditional equation. By conditional equation, all you need to understand is an equation with one variable, that is it. Okay. So basically, if I talk about some examples, it would have, let's say, 2x equals 2. Okay. Now, this is a conditional equation. It is self-explanatory. The condition is that the left side and the right side, they would be equal if and only if x is 1, right? So for such equations, which we used to call simple equation, this time we are calling it conditional equation, right? One variable and an equation. That is it, okay? For example, 3x plus 2 equals 4. Again, this is also a conditional equation. This time the condition is 3x equals 2, x equals 2 by 3. For both the left hand side and right hand side to be equal, for this to be an equation, this is the condition that x should be 2 by 3. Only then both the left sides and right sides would be equal, right? So this is why we call it a conditional equation. If I talk about some more examples, so you can think about it. This is the first one, this is the second one, then the third one could be 4x equals 5. What is the condition? Condition is that x should be 5 by 4, only then it would be an equation, right? And then if I talk about the last one, it would be 2x squared plus 3x plus 4 equals 0. So how do we find this? We basically factorize this, find the two values of x for which this equation is 0, and that is the condition. We need such values of x for which the equation gets 0, only then this would be an equation, okay? And that is the condition. So this is why one variable and an equation, this is called a conditional equation, right?
Um, According to this, every polynomial is an conditional equation. Yes or no?
Every polynomial. Okay.
Yes.
Now, if you are saying that it is polynomial equal to something, okay? Polynomial is just this. Polynomial itself does not have any equality or stuff like that, okay? So any polynomial cannot be equation because it does not have equality sign. But if I am claiming that I have a polynomial p of x equals to a constant, it could be any constant, let's say a. Yes, this certainly would be a conditional equation. You are 100% correct, okay? But this should be the case. A polynomial itself is not an equation. It's just an algebraic expression, that is it, okay? For equations, we need the equation sign. So this is important for it to be an equation.
Okay.
Okay. So are you comfortable with this now?
Yes, ma'am.
Okay. And then are you clear with identity and rational fractions?
Uh, yes, I know about the rational fraction, but can you repeat the identity
Yeah.
part?
Okay, sure. Okay, so this was the first thing, and then the second thing was Identity. What is the difference in any identity or any equation? Okay, now let's talk about, let's say we have x square minus 4 square. So, Asad, are you familiar with this famous identity, a square minus b square? We write it as a plus b into a minus b, right?
Yes.
Okay. So this is an identity because if I expand this side, I am going to get, we have x square minus b square on the left side. And if I expand this, I will get a square minus ab plus ab and then minus b square. So both the sides are same, okay? So a square minus b square equals a square minus b square. We do not have any condition here. If things are like this, both the left hand side and right hand side are identical. That is why it is an identity. So let's say if we have x minus 4 into x plus 4. This is nothing but identity because the left side and the right side both are identical, right? That is why it is an identity and it is not an equation. And if I just write down some identities, I'll do that just so you get the idea properly. This is the first type. The second type is a minus bx. What do you get when you do this? You get ax minus bx. Yes, left side and right side, they are identical. It does not have any other thing, okay? Both the sides are exactly same, so this is an identity. Let's talk about another one. Let's say we have a plus b square. It is a square plus 2ab plus b square. So again, both these sides are identical. There's no point in finding out the values of a and b because they are identical, they are same. You can just cancel them out directly. So such things are called identities, right?
Yes. Okay.
So are you okay with this now?
Yes, ma'am.
All right, okay, very good.
I have another question regarding that polynomial. So if we have a polynomial of degree 4, like x raised to power 4 plus x raised to power 3 plus x raised to power 2 plus 1. So will that be also an conditional equation?
Okay, you have a polynomial x square x to the power 4 plus x to
X
the
cube.
power cube and this, right?
Yes. Yes. Yes.
Okay. It
Is equal to
is
0.
going to, okay, very good. It is going to be a polynomial. It is going to be a conditional equation because you need some specific value of x in order to satisfy this equation. This does not hold for every value of x. What if I say x equals 1? This would be 4. What if I say x equals 2? This would be something else, okay? So for value, for some specific value, let's say for x equals 0, and then when you would factorize this, you would get 4 factors. Only then you would be able to have the values, and only then you would be able to claim that yes, this is an equation for x equals 0, for x equals this, okay? So you would have 4 values of x which would satisfy this equation. So again, this is a conditional equation, right? One variable, x is one variable, and an equation. Yes, that is an a conditional equation. You are correct.
Okay, ma'am. Thank you.
Welcome. Okay. Right. So Zahib, anything that you would like to ask?
No, ma'am.
Okay, then this is good. This is enough. We'll talk about sequences and series in tomorrow's class, and then we'll try doing the questions as well. All right, so I'll stop sharing the screen. I'll stop the recording. Thank you. Take care.